Water Corporation is the main supplier of water, wastewater and drainage services in Western Australia. It helps to ensure we have enough drinking water for the future by developing new sources, increasing water recycling and encouraging efficient water use.
Very good, Isla. Have you ever wondered where the water you use in your home goes? You know, the wastewater from your shower, sinks, washing machine and toilet.
Every day, each of us produces about 200 litres of this wastewater, enough to fill a bathtub. Although it is 99.97% water, it also contains oil, greases, detergents, nutrients and bacteria.
So where does it go and what happens to it? Let's find out.
The wastewater from your home flows by gravity or is pumped through pipes and into a network of larger pipes called sewer mains. Its destination is a wastewater treatment plant. There, it goes through a series of treatment processes to make it safe enough to return to the environment.
Today we're going to take a look inside the Beenyup wastewater treatment plant in Craigie. It takes wastewater from homes and businesses in Perth's northern suburbs. But first, I need to change. Ta-da! Hi, Siobhan.
Hi, Oscar.
So, Siobhan, is this a typical wastewater treatment plant?
Yes, most wastewater treatment plants use similar processes. However, they can be different depending on where they're located and how much wastewater they treat. This plant can treat 135 million litres of wastewater every day.
Wow, that sounds like a lot.
Yes, that is enough to fill about 54 Olympic swimming pools.
Not that we'd want to swim in it.
No, definitely not.
So, where does it all start?
Well, let's have a look.
The first stage of the process is called preliminary treatment, but to start with, we're going to see where the raw wastewater comes in.
This is what we call an intake channel, and it's coming from more than 500,000 people in the northern suburbs. Once it's here, it flows onto the screenings building over there.
It's not in the pipes above us, is it?
No, this is actually part of our odour control, and we'll have a look at that later. The wastewater is actually flowing beneath us using gravity, and in fact, the flow from this plant to the ocean is all using gravity.
That's impressive. You're saving energy and I'm guessing money.
Yeah, let's go. The first thing we do is remove large objects like rags, plastic and rubbish. This is done with specially designed filter screens, and this part of the process is called screening. The rubbish that's collected here is taken away and disposed of at an approved landfill site.
What kind of things get screened out?
You'd be amazed at what we find. Cotton buds, false teeth, even Barbie dolls. They really clog up the system and can damage equipment, which costs a lot to replace.
So we need to avoid putting things like that and other rubbish down the sink and toilet.
Yes. After screening, the wastewater is sent to these grit removal tanks so that the inorganic material, they're the bits made out of rock or mineral, can sink to the bottom. The water is drained and flows on to the next stage. The grit is washed and sent to an approved landfill site, together with the screenings.
So it goes back over there, into one of those bins?
Yes, that's right. Now it's time for primary treatment. These sedimentation or settling tanks help remove most of the solids in the wastewater. So inside each tank, the solids form a sludge at the bottom and mechanical scrapers push it to the end of the tank. The sludge is then pumped to the sludge treatment area, and we'll have a look at that later too.
So what is the wastewater looking like now?
Well, here's a sample. You can still see some bits in it, but it's a lot clearer than when it first came in.
Wow, you can really see the difference.
Yeah.
So this wastewater is now going on to the next stage?
Yes, onto secondary treatment. Under these covers are the aeration tanks, where mechanical blowers pump air into the wastewater through fine membranes on the floor.
But where does the air come from?
Through that big grey pipe above us, that takes air from the aeration building through to the tanks.
Why do you need aeration?
Well, the microbes, which are the good microscopic bacteria, need oxygen to survive.
While the microbes are in the aeration tanks, they break down and gobble up all the remaining organic matter and nutrients in the wastewater. By the time they've done their job, the wastewater is almost ready to return to the environment.
So you're not using lots of chemicals to clean the wastewater?
No, it's mostly natural. If we used chemicals, we'd have to have another process to remove them before returning the water to the ocean.
After the aeration tanks, the water flows through to the secondary sedimentation tanks.
These don't need to be covered because the water is pretty clear and doesn't smell. The water overflows the perimeter of the tank, and now it is safe enough to return to the ocean. The algae you can see is just a sign of nature at work.
Where does the water go now?
Over to that yellow concrete block.
So this is where the treated wastewater begins its journey back to the ocean environment.
Yes, the big pipe you can see is taking water from here out to the ocean, all by gravity. So this is the end of the treatment process at this plant, but...
It's not the end of the water cycle. That keeps going.
Correct.
Once the treated wastewater reaches the ocean, a long pipe takes it out to sea. The pipe has small holes towards the end to help disperse it evenly into the sea. Salt, sunlight, oxygen, and ocean currents all combine to continue its treatment. To make sure it's not harming the marine environment, there is regular monitoring and testing. Ocean outlets are the most cost-effective way to manage treated wastewater because they use very little energy.
Okay, we've seen where the treated wastewater goes, but what about all that sludge? Where did that end up?
The sludge comes into this area and into these heated digestion tanks, where it is broken down by bacteria. The tanks are 8 meters high and go down 8 meters into the ground. And each one holds 4 million liters of
Sludge? Ew.
We then remove the water from the digested sludge, and what we're left with is something called biosolids. These are trucked off-site to be made into fertilizer or used in agriculture.
So what's that weird looking tank over there?
That's for the methane gas produced in the digesters. Some of it is used as fuel for heating and mixing inside the digesters.
What about the odors? I've noticed it doesn't smell too bad around here, considering what comes in.
The smells could be pretty unpleasant, but we do everything we can to reduce odours. We cover those parts of the plant where smells could develop and take odours from those areas through the overhead ducting into chemical scrubbing stacks. Inside these stacks, hydrogen sulfide and other odorous gases are removed, and the treated air is released into the atmosphere through those two stacks.
They look pretty high.
They're 50 meters, high enough to ensure any remaining odors are dispersed into the air. Finally, we have the control room.
There's quite a lot going on here. How do you know it's all working properly?
We have monitoring points throughout the plant, and they all feed here into the control room. We can keep track of what's happening, how the equipment is working, the quality of the water, and just generally keep things running smoothly.
So, sounds like you've got it all under control.
Yeah.
Okay, I guess we can leave you to it.
Great, thanks Oscar.
See you, Siobhan.
See you around.
Bye. Well, now you know what happens to wastewater and why it's so important to be careful with what you put down sinks, drains, and toilets. By putting rubbish in the bin where it belongs, you'll help keep the system running efficiently. Speaking of systems running efficiently.
Oscar, can I please go to the toilet?
And so the cycle continues. Sure, come on, Roman.